Next up, we have oral presentation 29, Burleson, Texas, Mission 12 Flight Experiment.
Hello, my name is Ian Ray, and we are the team Penicillin Mold Growth. This is Kenneth Sanders and Ryder Huskins, co-investigators for our team. Kate McCarthy is our principal investigator, and Ethan Moore and I are the collaborators. We are 6th grade students who attend at the Realm Kerr Middle School. Our teacher facilitator is our science teacher, Ms. Laura Smith. We represent Burleson Independent School District in Texas. Our team's experiment is penicillin mold growth and microgravity. Our question is, what effect does microgravity have on penicillin mold growth? The purpose of our group choosing penicillin mold growth in space is because throughout history, millions have died due to simple infections caused by bacteria. Alexander Fleming was the man who discovered the benefits of penicillin mold, and this discovery saved millions. There are many reasons for the experiment, such as whenever or not penicillium grows faster in microgravity than on Earth, or whenever we can produce more medicine for people who have infections. Additionally, we do travel to Mars and need medicine. Antibiotics can grow, and Sheetrix spores can make their own. In order for this to happen, we need to know how long it takes to grow, or even if it will grow in microgravity.
This experiment answers our question because we can compare the different amounts of mold growth on Earth and in space. One of the problems we had was making sure the growth started and stopped in space. We fixed that problem by adding a glass tube with 1.5 milliliters of potato dextrose agar and 0.05 milliliters of penicillium mold. We decided to release formalin to stop the growth. Another problem we had was using the right amount of mold. This was a pretty big problem because if we used the wrong amount, it could ruin our experiment by making it hard to compare the two. We decided how much we should use by experimenting with different amounts at the Texas Christian University biology labs. In these pictures, you can see us walking on this experiment. In the top right, you can see us at the TCU Student Research Symposium.
Our experiment requires a type 2 FME, a small glass tube, 0.05 milliliters of penicillium mold, 1.5 milliliters of potato dextrose agar, and 2 milliliters of formalin. First, we had to make agar slants in the small glass tubes in preparation for loading the FME. Next, we needed to make sure the FME was sterilized in order to prevent contamination. We put the clamp on the tube to create volume 2 and filled it with 2 milliliters of formalin, and then put the stopper on. We then had to inaugurate the agar with 0.05 milliliters of penicillium mold and place the glass tubes open and facing volume 2 inside of volume 1. Then we sealed volume 1. Next, we sent the refrigerated mini-lab to NanoRacks and NASA in order to keep the mold from growing while on Earth. Once it arrives at the International Space Station, since it hasn't arrived yet, it will warm to ambient temperature to allow the mold to begin growing. 2 days before undocking, the clamp will be opened, releasing the formalin and stopping the experiment in space. This will ensure that gravity will not influence our results when the experiment returns to Earth. Once it is back, we will examine the sample and compare it to the ground truth experiment.
The expected results of our experiment, our question is designed to answer the question, how does microgravity affect penicillium mold growth? The expected results of our project is that penicillium mold will grow better in microgravity. We believe this because there are less forces acting upon the sample, such as gravity, and because of previous NASA studies showing how microorganisms grow faster in microgravity and may mutate from their Earthen counterpart. When our experiment arrives back on Earth, we will examine it at the TCU labs with microscopes, scales, and visual observations. We will do this with the help of Professor Dr. Clark Jones, and will have access to their lab equipment as shown in one of the images. We will examine the sample by taking its mass, observing structure, color, and other chemical and physical changes. We plan to do our ground truth experiment multiple times after the main experiment has landed to get a wider and more accurate range of data to compare our flight experiment. We are expecting the penicillium sample to be bleached by the formalin. We believe the experiment, as we've designed it, will inform us about penicillium mold growth in microgravity.
Once we receive and analyze our results, our next steps will be to research and experiment how we can make penicillin antibiotic from penicillium mold and microgravity. We are excited to continue our research and endeavors in the future. We would like to thank SSEP, DreamUp, NanoRacks, CASIS, the Texas Space Grant Consortium, Burleson Independent School District, The Realm at Kerr Middle School, especially Mrs. Laura Smith, our teacher facilitator for this proposal. Lastly, we would like to thank our mentors at Texas Christian University, Dr. Clark Jones from the TCU Biology Department and Dr. Magnus L. Ritby of the TCU Department of Astronomy and Physics. Everyone mentioned here was helpful and necessary in ensuring this experiment was successful. Thank you.
Do you know about any other antibiotics that would be made from a mold similar to penicillin? And do you think your findings would apply to those as well?
I do not currently know of any other ones that are made from penicillin mold, but we do know that a lot of molds have beneficial, they kill bacteria. This is one that's been widely used though, so that's why we chose it. Yeah. Because it's penicillin, and it's been used to treat many infections, and it's proven.
Okay, thank you.
Hi, I'm Abby from Belen, New Mexico. And first of all, I would just love to say that the bow ties look great. And I think everybody can agree on that.
Thank you.
But my question is, what did you use potato? And could you just elaborate on why you chose that and what it exactly is?
We actually did research into the types of agar that is best suited to grow Penicillium crassigenum, which is this type of mold we're using. And potato dextrous agar was the best type to use.
Okay.
For many people, that's what they used.
Thank you.
Thank you, ma'am.
Do we have any further questions? Okay, thank you.
Thank you.